Cool.
Greg, do you want to start now? It's 9:11.
That sounds good.
Okay.
Okay. All right. Hi, everyone. Here, I'm going to share my screen to start off. Okay. So this is a tutorial on Matplotlib. It's part of the Python series. And Matplotlib is, so basically this is an introduction to plotting. There's actually a few different libraries you could use for plotting in Python, but Matplotlib is the most popular and the best. It's called Matplotlib because it's supposed to, its syntax is supposed to be similar to MATLAB's plotting syntax. So if you're familiar with MATLAB, that could help. That's what the Pythia says, which is a tutorial we'll be using. But if you don't know MATLAB, that's okay. You can just learn Matplotlib instead. Okay, so before I started, I just wanted to first introduce some of the terminology that I'm going to be using. So this tutorial, and we'll see how far we get. We might get all the way to histograms and color bars, but we'll see. But all of it, everything that we're doing is going to be for two-dimensional plotting. So that's just a plot that looks like an image on a piece of paper. And so in a two-dimensional plot, and the little figure on the right is calling it the image on the right is calling it a figure, but we use the words plot and figure sort of interchangeably. So this image on the right is introduces some of the terminology that we'll use. So we call the two-dimensional plot has two axes, one vertical axis that goes up down, and we usually call that the y-axis, and it has a horizontal axis that we often call the x-axis. That's like for historical reasons, that's why we call it that. And it's kind of a busy image, but it shows you there's three information is shown in three ways on this plot. You can see a blue line, and it's giving you also the Python command, which we'll get into, which is the way that you create that line, but don't worry about that right now. So the blue line, we call it a line. It's one way of plotting, X versus Y. And then there's an orange line. And then there's also markers, which use a different command. So that's like just putting little dots where all of your data is. There's a thing in the corner that's called a legend. The legend is actually incomplete in this image, which I think is funny because it doesn't have the markers on it. But anyways, you still get the idea, I think. And then there's some other details that don't matter so much, like and I've lost my mouse, so I might have to go out of presentation view. But these little things here are called ticks. And and there's actually two types of ticks. There's big ones and there's small ones. So there's major and minor ticks. And then finally, I guess the last thing is that these dotted lines in the background are called the grid of the plot. Okay, so that's just a little introduction. We'll go over that again in a few minutes. And I just wanted to, before we get into the tutorial, I wanted to give you a little a teaser of what you might be able to create eventually once you master these plotting techniques. So this is a movie that I've made using Matplotlib, which visualizes ocean turbulence. So, you know, after assembling all the pieces together, this is actually in 3D, but the idea is the same. It's sort of just 2D, but like with some fancy, you know, visual effects to make it look 3D. But you see, you know, I have axes and I've plotted it, and then I plotted many frames in succession, which then led to a movie of turbulence. Okay, so let's start coding. If there's any questions, I could answer that. Yeah, probably not at this early stage. Okay, so now I'm going to, so I think it's helpful if you would like to, you can follow along. Actually, I'm not sure if this link will work if I just paste it in there. Maybe Daniel or Shanice, if you want to, you could paste the link to open up the notebooks in the cloud. I don't know if that'll be helpful to people or not. But so I'm in the, I'll show you where I am. When you open this Quessing folder, there's a folder called Pythia Foundations. So we click on that. And then the Matplotlib tutorial is going to be in the core folder under Matplotlib. And there's 3 notebooks in here. And we'll just start with this one called Matplotlib Basics. And there's 2 more that we probably won't get to all that material, but you can look through it and run it on the cloud if you like. Okay, so just let us know if you have trouble finding the notebook or if you need the link again. Okay, so here's the notebook, and you can see, so the first cell of code is here, and it has this code that if you make a lot of plots, you'll come to know and love very well. And this is a convention that we always import matplotlib.pyplot as PLT. So I don't know if this is helpful, but I'll just type this for you. So we at the top of any notebook that you're using for plotting, you're going to write this import matplotlib.pyplot. And that will import, you know, that'll give you access to all these commands that will prefix with the letters PLT. We're also going to import NumPy because all of the data that we're going to be plotting is going to be contained in NumPy arrays. So we need NumPy too. Okay, so I imported that. And then the next step is just Pythia has created some, well, I don't know if it's fake data. It's data of some kind. So, you know, when you go to make your own plots, you'll have your own data, hopefully. But for this tutorial, we'll just use this data. So I just load that into the notebook. And now here's a summary of the things that we just talked about, what the figure looks like. So the figure is what in Matplotlib is the entire image. And then the axis is the grid that is inlaid within the figure. Okay, so when you create a plot in Matplotlib, and here's, I'll type this all out. So to create a figure in Matplotlib, we first we use the function plot.figure, and we can also I think it's optionally, we can give it a size. Okay, and it doesn't I guess it doesn't look like anything because there's no axis in it. And so once we've created a figure, then we can put an axis in it by asking for a subplot. So it's a subplot, like we could add more than one axis to a figure. That's why there's this function subplot. But in this case, we're only going to add one. Okay, so we added. Okay, so when I executed these two lines, now it's displaying the figure with an axis in it. And by default, it's just going from the X and the Y axis go from 0 to 1. Okay, so next we are going to fill this figure with data. And we'll use, so we had this times data. I'll just make sure we have that yet. Times and temps. Okay, so to draw a line, we'll write ax.plot times temps. And there we go. It creates by default, this is by default, the color is blue. And you can see that on the x-axis, so that in the function signature, the first argument is the x data, and the second argument is the y data. So the x data, the times, and I guess we're going to find out what units these are. Maybe hours go from, around 90 to around 160, and the temperatures are going from 285 to 310. So apparently these temperatures are in Kelvin. Okay, so yeah, now, okay, so we created a plot, but if you want the plot to convey information, you have to say what the axes mean. So to do that, we add axis labels. And I'll just do this, code this for you. So, well, okay. So first we were going to add an X label. And as I was saying, that's time. I'm going to redisplay the figure. Okay. So the difference between, you can see in this plot, neither the X or the Y axis had any labels. And then here we have the label time appearing. I'm going to take the liberty. Let's see if we can figure this out. So I think it doesn't look like, I'm just going to guess that this should represent hours. So if you want to, just practice changing the labels, and that will help you remember all these plotting commands. You can try changing this too in your notebook. So if I change the text there, then I get an hours here. And it's a good practice to always put the units. If your if your data has units, the X or Y axes of your data have units, then it's good to indicate what the units are. So the next thing is we'll put in the Y label, and I'm going to take the liberty of adding units to that too. Degrees, Kelvin. Okay. Okay, so that's how you put data into a figure and add X and Y label. If there's any questions, I see there is something in the chat. Okay, no, that's, she needs to put the help link. All right, so just, at any time, feel free to interrupt me and ask questions. Okay, so next up, we're going to add a title, which is just something that, says generally what the plot is, what the data, the subject of the data. Sometimes you don't need a plot. You don't always need a plot title if the X and Y axes are clear, but it can occasionally be helpful to have title. So to do that, we use this command set_title, and just from the Pythia, from the original notebook, I know that this data is referring to a temperature forecast. Display it. Okay, so now when we added the title, we get this text at the top of the plot. And yeah, the tutorial notes that, so what we just did here is we've set the X label, we set the Y label, and we set the title. There's a huge number of other things other like aspects of the axis that you can change. Like you can change the ticks here, you can change the labels for the ticks, you can add, this only has major ticks, but you can add minor ticks, and so on. And it's too numerous to list here for now, so we'll keep going. Okay, so now okay, so the next thing is we're going to add another list of data which has corresponds to the same times but has different temperature information. So we add that. That's gonna allow us to illustrate plotting two things on one plot. Okay, so now we're gonna plot two things on one plot, and we're gonna add grid lines and a legend. So let's go through this. Line by line. Get rid of that. Okay, so first, just like before, we're going to create a figure, and we're going to use the same figure size. So you can experiment changing these numbers. This is the size in X and the size in Y, if you want to create a figure with a different size. And then we'll do it just like what we did before. We'll create an axis. And then we're going to plot the same data that we did before. Oops, plot times temps. Okay, so this is the data that we plotted before, but this time, because we're going to plot two, we're going to make two lines. We want to label the lines so that we know which is which. Okay, so so we're going to label this data that was in temps. We're going to call that surface, and then the second piece of data. Let's see. Let me just temps 1000. I think was what it was called. Oh, times. Yeah. Okay, so temps 1000 is this other array. So I'll say ax.plot times temps, and apparently this temperature data is referring to temperature taken higher in the atmosphere at a pressure of 1000 millibars. So don't worry if you don't know what that means, but suffice to say that it's different. The temperature data was taken at a different place. Okay, so now we created a plot with two lines. Notice that I labeled the data. So when I made each line, this is plot creates a line. I forgot to turn my video off. Okay, when I created each line, we labeled the data by adding this label keyword here, but it hasn't appeared in the plot yet. Okay, so you'll see. So I'll show you how to make. So I'll show you what these labels do in a second. Or actually, I'll just do that right now. Let's see. So what the labels do is that when you then go to add a legend to the plot, which you do with this command ax.legend, it's going to use those labels. Right. So there you go. And in this, they're putting it in the upper left, but I think it should be in the upper right. Okay. So yeah, so you can see by changing this location string, you can move it from the left to the right. By the way, I guess I should have said too, this might be useful if you want to know. So I think this will work. If you want to get the help string in the notebook, you write this question mark and then the name of the function. And so down here, it's printed out the help string into the notebook, which can occasionally be useful if you're trying to figure out. Okay, so yeah, so here, for example, this location argument, it's saying it can be upper left, upper right, lower left, or lower right, and that's going to control where the legend appears. So if we go back up, I wrote upper right, but if I wanted to put, if I want to put the legend in the lower right down here, then I'm going to type, let's see, lower right. Oops, and I want to print the. Yeah, so you can see it showed up in the lower right. Let's put it back in the upper right. It's a better place for it. Okay. Okay, so let's go on. Okay, so all right, we have a legend, and then we're going to add these, the X label and the Y label like we had before. I'm going to put my units on it. Oh, temperature, degrees, Kelvin. And then set title. Sure. Yes. Okay. See what it looks like. Nice. And then the last embellishment we're going to add in this section is to add a grid to the background. So that's going to add these lines that go straight up and down and left and right, which will help us interpret the data. So that's just, we just say grid true to turn that on. Okay. So are there any questions about that? All right. Okay, so when we created these two lines, it created a blue line and an orange line. I'm colorblind, by the way, so if I mix a color up, you can just let me know. It's useful that they're different colors because you know that's how we tell the difference between the lines. But you might want to, you're not restricted to only using the default colors. So I think we can show you how to, here, and let me go here. So let's look into how to change the color of the line according to, and make it look the way we want to look. So, okay, so first I'm going to create that first line. So I have these first two lines are the same as they were above, and then I'm going to a third line that plots the data. It's going to have the same label, temperature, surface. But now I'm going to add another. These, by the way, when you write, label equals something, that's called a keyword argument. And then these arguments here, which don't have an equals, those are called positional arguments. So in this, what I've written here, I have two positional arguments, then I have one keyword argument, and now I'm going to add a second keyword argument to indicate the color of the line, and I'm going to make it red. That's what the example does. You can look up. I think this worked for me, and I'll just demonstrate. You can use Google to try to find the colors, line colors. And I believe, yeah. So, yeah. So so if I just Googled Matplotlib line colors, and this page came up, which tells me, so in this example, we were using tab red, which is right here. But we could have written any of the colors in here, and use those instead. So I could show you what that would do. Like, for example, if we use sky blue. Oh, that's not what I want. Okay. Yeah. Okay. Phew, it worked. Okay, let's go back to red, just like the example, even though, yeah. Okay. So that creates a red line rather than the default blue line. And then the next thing I'm going to illustrate is how to create another line. And we're going to, rather than distinguishing these lines by different colors, we're going to distinguish them by their line style, which is going to be whether they're dotted, dashed, dash, dot, or solid. I think those are all the line styles that you can use. So to set it as the same color, I'll say tab red, and then I'll set the line style as this string with 2 dashes in it. See what that does. Yeah. So if I put a string with 2 dashes in it, then that second line is going to be, has this appearance where there's little gaps in the solid line. If you write, I think if you write colon, so this is a dotted line, right? But I'll just go back to the dash line. Okay. There's a question. Why do we have tabs? Yeah, that's a good question. The reason why the colors are named that is because it's somehow it's from these this list of colors that's called the tableau colors. So that's what tab means. It's just the name. The XKCD color, this is from, it actually has a link here. It comes from this comic called XKCD, which is defined the names of all these colors using a survey. So it's just a convention, and that's why you have to look it up or memorize it, which is a good policy to memorize the colors. Yeah.
I miss a lot.
Let's say that again. Oh, okay. All right. So let's go on with this little example. Actually, I don't think I need to do everything. Maybe I'll just add a legend so you can see what the legend looks like, and then we can move on to the next thing. Upper left. Yeah, and yeah, I like it in the upper right. Well, doesn't look like it helped as much. It's nice if the legend doesn't cover up the data, but anyways, let's not worry that too much. Okay, so now we're going to move on, and we're going to bring the complexity up further by adding a second plot to on top of the first plot. Is it possible? Yes, I believe it is. I don't know off the top of my head how to do that though. So there's a question: is it possible to make the legend background transparent? And I think there should be a way to do that. Let's see what it says here. So frame alpha. Yeah, so I knew what I was looking for, so that's why I was able to find it so quickly. But so there's an argument frame alpha to that function that sets the transparency of the background. So let's see if we can make that work. Frame alpha equals 0. Just guessing. Yeah, okay, so it worked. Okay, so you can see if I set frame alpha to 1, then the legend is solid, it's not transparent at all, and you can't see the line behind it. Here, I'm referring to this part of the plot right here. So you can see the legend is covering up the line. If we set frame alpha equal to 0, then the legend becomes completely transparent. It's still not that easy to interpret, but you can see the data behind it. Okay, good question. All right. So moving on. Okay, so now we're going to subplots. So I'll do this exercise of typing things out for you. We're going to plot the other piece of data. I guess it's kind of boring. We're just going to plot the dew point, which is 0.9 times temperature. So it's going to look pretty similar, but anyways, it'll still be useful. Okay, so create a subplot. Wait, yeah, get rid of that. First, I create a figure the same way that I created figure before. So, you know, since I'm going to have 2 subplots in this one figure, I might want to make it a different size, but here I'm just going to use the same figure size. Here, actually, I'll make it a little wider just because, yeah, it'll look better. Okay. And then next, I'm going to add a subplot. I'm going to use a different syntax than I used before, though. So now I'm going to say I want to add a subplot to the 1, 2. So what this says is that in this grid layout, there's going to be 1 plot in the vertical. So there'll be 1 row. But there'll be two columns, so two plots side by side. And then this axis is going to refer to the first of those plots. So basically, it's going to look like this. And then the this one here is referring to this one. And then the second one is going to be a 2. Okay, so let's keep going. So you'll see what happens. So now I say ax plot, put the data in it, times temps. I'll just do that first. Let's just put the add subplot 1, 2. So it's 1, 2 again because it's the same layout, but now I want to refer to the second of the two subplots. And I guess Pythia is recommending that I do 2, so that's good. X subplot times dew point. Okay, now good. So you can see that it plotted the second subplot. Sorry, it plotted we plotted the dew point in the second subplot. And you know, I might want to add a y label dew point and x. So sometimes when you have 1 and 2, sometimes it's nice to call it 1, x1 set y label. Sure. Okay. Is there anything I think this would actually look a little bit better if I wrote it. I'm gonna make it wider. Oops. Figure size. Okay. So you see when you change the figure size, it changes the appearance of the plot. So if I wanted both plots to have a similar aspect ratio, I can change the vertical size by changing that second argument. Can you explain the subplot variables and relate subplot? Okay, yes. Yes, so well, so the temperature is being plotted in subplot 1. And the dew points being plotted in the subplot 2. The arguments 1, 2, 1. So what that means is that here, let's let me illustrate it. So okay, so the first argument is the number of rows. So if I draw a grid, this is definitely confusing, by the way. So it's a good question. I'll just draw a little grid here. So the first argument is the number of rows, right? So that's the row. Trying to draw here. The row is these are rows, right? Each horizontal line of plots. So because we wrote 1, it means that we want to create a figure that has just 1 row of subplots. That's the first number, this one. The second number, which is the 2, refers to the fact that we have 2 columns. So this is column 1 and this is column 2. So the first 2 numbers just say how many subplots in total we're going to have in the image. Then the third argument is indicating within this layout that has 1 row and 2 columns, which subplot are we referring to? So which subplot would we like to add? The first one or the second one? So I can, hopefully that explained it. I'll say it with I'll just embellish this example to try to drive the point home. So let's add a third one. So if I wanted to say I wanted to add a third subplot, then I would add another line, and I have to change the whole thing, the code that comes before too, because now I want to add a third subplot. You say I wanted to add a third row. So I'll change the first 2 numbers to 1, 3, 1, 3, 1, 3, and then axis 3, I'm going to say is, yeah, let's say, well, I'll just add the horizontal line. Let's see if this works. Yeah. So, okay. So hopefully that illustrates what happens. So before, so if I comment these out, okay, what we had before is we had two rows and two plots. Then we wanted so we had 1, 2, 1, 2, and then 1. It's really hard to say in words, but anyways, hopefully you understand what I'm saying. To add a third column, we change the first two arguments to subplot from 1, 2 to 1, 3, and then we add the third axis. And it's what distinguishes the third axis from the second one and first one is the third argument. This will take a while to internalize, I think. It's not took me a while. So yeah. I didn't find that to be the most intuitive aspect of plotting Matplotlib. Okay. So there's a convenience syntax for creating all of these subplots. You can do it in one line. And that's what's being shown here. So if we run this line. So let me see. Okay, we've got 15 minutes. So I think we'll see. We're not going to get to the end of this, but I think, does anybody want me to skip ahead, or are you happy with the pace that we're going at? Okay, just message in the next 5 minutes if you'd like me to skip ahead to contour plots or something like that. But for now, I'll just fine. Okay, so the next thing is we're going to show this compact syntax for creating a plot with any number of subplots. So there's this function, it's called subplots, and it has these keyword arguments, n rows, n calls, and fig size. Okay, so this syntax creates a subplot with 1 row, 2 columns, and this figure size. And as I was saying before, I kind of like to make it a little wider. I think it looks better. I can just maybe illustrate, if you add rows to the plot, then you see, it's gonna, so if this creates a 3 by 2 plot, that's 3 rows, 2 columns. Go back to the original one. Okay, and so now this axis object is an array, actually, that has two entries. So the 2 entries are the 2 subplots. So now, if we, in order to plot into the first subplot, we index into axis at the 0th index, and then we'll put create a line there. And then similarly, if we want to put a line into the second axis, we can, do point. Yeah. Okay. Line style, just so they look different. Yeah. Now, as before, I'll just illustrate here. So before we were adding a title to one axis, but we can also add titles to each to each subplot individually, right? So we use set title again for that. See, yep, and set title. Okay, so again, we can use the set title to add a title, and the title is going to appear over each axis within this bigger figure. And it's the same thing applies for, let's see if this is the forecast, and then the same thing applies for the X and Y legend. So set X label, that's the times. Okay, so that's going to be the same for both of them. So I'll just, yeah, okay, so I set that, and then set Y label picture. Oops. Yeah. I would maybe just make one comment about the arrangement of the plots. Oftentimes when you have data like this where they share an axis, so in this case, both the temperature and the dew point both share the x-axis, it can be nice to arrange them on top of in a different, so I would, it's worth exploring putting the two subplots on top of each other. So we do that by changing the rows to 2 and the columns to 1. Let's see if that worked. Yeah. And so you see, if we change the rows to 2, now we have 2 rows and 1 column. And because these two pieces of data share an x-axis, you can compare it's easy to compare the data at a particular time, because just by eye, you can draw a line, for example, through 100. You can say, okay, when the time equaled 100, the temperature was, 295, and the dew point was, 280 or something like that. So that's just a comment on presentation. All right. Okay, so let's see what we've got next. Setting the X and Y limits, that's important. Okay, let me do that up here. This will actually illustrate the point, I think, pretty well. Okay, so another thing that's useful sometimes, so when we created this plot, we had data, I guess if we look at the times, let's see, the times go from 93 to 162. And the Matplotlib somehow decided to make the whole plot go from time equals 90 to time equals, 165 or something like that. But we have control over that too, so we can change it. So if I want to change the X limits to say 80, one set, am I using, yeah. Yeah, so say I want to change the X limits and show more, or I want to show less, maybe. I only want to show a subset of the data. Then I can use this command set X lim. That means set X limits. And that sets the where the axis starts and stops. Okay, someone had their hand raised, so please ask your question.
Yeah, Greg. This is Joshua. I see that. Is there a way we can create? Oh, okay, that's gone. I was seeing. Okay, I see that the title for dew point forecast was overlapping on the values.
Yes. Yeah, so we want to create, and now actually I don't know the syntax for that off the top of my head. But what you want to do is we want to create more space between these two subplots. Let's see if I can figure that out. Create space subplots, Matplotlib. Okay. So I think this is going to explain how to do it. Okay, let's try this. We'll use figure tight layout. Okay, so tight layout pad 5. Let's see what that does. Oop, that's too much. But okay, so yeah, so there are commands for that. That looks good. Yeah. Another, okay, so there's this command tight layout, which it's funny because actually typically you would use this to make the subplots get closer together. That's why it's called tight layout, but you can also use it to add a padding between the subplots. I think this pad is a horizontal and a vertical padding. Another way to do that is so here we have the problem here. Another way is to change the figure size. Sometimes it kind of spaces things out a little better. Although actually it's not helping that much. So we don't need to add the padding. Okay. Thanks. That was a good question. Another thing you can do, if you have two plots like this, sometimes it's kind of a judgment call, but you can actually eliminate the X label because they're redundant. They have the same meaning. So if you get rid of the X label, that can help, you can also get rid of the ticks, the tick labels. Okay, so yeah, we were discussing setting the X limits. I think, yeah, the only final thing I would say is that if you're going to change one of the X limits in a plot like this, you're going to change both of them at the same time, because now if I only change the top plot, then the top plot goes from 100 to 150, and the bottom one goes, it has a different X limits. I would recommend setting them the same if you're going to change them. Okay. And I think actually there's another way to do that, and I just figure that out. So can make it happen automatically, I think, by saying share X is true. Okay, so let's see if that works. Okay, so remember what I'm discussing is the fact that if you change the X limits on one plot, it doesn't change them on the other plot, and that's undesirable if the two plots are meant to have the same X-axis. One way to make it automatic is to use this keyword share X equals true. And okay, yeah, so that works. Okay, so if we say share X equals true when we build the subplots, yeah, I guess if you're not talking, can you turn off your mic? That's the request. I don't know if I'm able to do it myself. So, okay. Okay, so yeah, okay. So if we when we build the subplots, if we say share X equals true, then if we change the X limit on one of the plots, it's automatically going to change it on both of them. See, so so now you can see I'm only changing the X limits on the first one with index 0, but fortunately it's helping me out, and it's changing. It knows that both the first and the second plot should have the same X limits, so it's changing the second one as well. Okay, so yes, I anticipated it. All right. Well, now things are getting a little more complicated. Let's see that. Okay, so let's build up to what we have below. So then, I guess the next thing that we can do, I'll just illustrate one more thing, I think, because actually we don't have too many. Oh no, I'll illustrate a few more things, but let's just illustrate one of the things in that next section. So the next section, the cool thing about this plot, I think, is that it shows you how to put a marker on the lines. And so if we go back, so we had the temperature forecast and the dew point forecast. We plotted the dew point here. If we want to add a marker, so by default, there's no marker. But if we add a keyword argument to plot and say marker equals, so there's many markers that you could choose from, but here I just chose sorry, it's hard to see. Okay, I chose this is the letter O. And it puts circles there. Let's see, I think a square marker, you have to memorize all these things, I guess. Yeah, so to do with squares, use the square symbol. To use an O, I mean, sorry, to do circles, use the O. And I'll just show you so if you have two, it's especially useful if you have more than one data series. So if I plot another line, and let's use a marker here. No, I don't think you can share. So there's a question, can you share markers? I guess, like, can you say, can you ensure that all the plots have the same markers? I don't think you can do that with one command. I think you have to type it in manually. See if that, oh yeah, okay. So a star is indicated with an asterisk. And then down here, we can add a legend to that axis. Oh, what did I do wrong? Let's remember how to do a legend. Oh, I had a bug. Hold on. Huh. What am I doing wrong there? Location. Left. No, it's not working. I'm not sure why that legend isn't getting added, but maybe it has something to do with wait, let's see what they, because they put a legend in here. Well, maybe it doesn't look like I'm able to. Oh, I don't have any labels. That's why. Okay, so that was teaching moment. Okay, so I tried to add a legend to the plot, but there's no labels here, so it doesn't know what to call them. So, okay, so I'll call this temperature surface and temperature. Okay, now it worked. Great. Yeah, lower left maybe might look better. Actually, if we set the xlims, then there'll be a little more space. Okay, looks kind of weird. Yeah. Anyways, when you add the markers, what you see is that they show up in the legend as well. So the legend is showing the line style and the marker, or the marker that's being used, line style. Okay, great. So we're 2 minutes over, but I think we got through all of the a lot of the line stuff. Definitely, if you want to keep learning, I recommend going further. The next section is going to discuss scatter plots. And eventually, yeah, interesting. Eventually it gets to a section that I think is interesting, especially for for doing things that have like plotting environmental data where you often have maps, color maps. So that's the section below. It shows you how to use this function, this very useful function imshow, as well as contour and filled contours. Oh yeah, the lecture will be, it's being recorded and it's going to be posted online. There's a question, can we have access to the lecture after? And the answer is yes, definitely. Yeah. So I think, yeah, the heat maps and the contour, I would definitely recommend reading that and explore and going through the notebook to learn how to create create and plot spatial data. Especially useful for creating maps, which is the subject of the next tutorial coming up. I think it's going to start a little bit late. So maybe I can just start with this imshow illustration while we're waiting. I don't know if that's okay with everybody.
Yeah, that's fine for me.
I can't see anybody, but yeah. Okay. Let me just send a message to the next instructor.
Hello, Craig.
Hey.
Yes, so I think probably it could take an extra 5 to 10 minutes. Kevin is running a bit late.
Okay. So we'll just keep going with the tutorial. Sounds
Sure.
good. Okay. All right. So let's do heat maps. This is my favorite. I like, plotting lines is good. But I think plotting heat maps is even more fun. Okay, so now I'll try to just illustrate plotting a heat map, and this is using this function imshow. And in order to do that, we need to create fake data. So that's what's being done here. So basically, it creates it uses this function mesh grid to create two arrays x, y. Let's see. So these arrays are just two-dimensional arrays. Both of them go from -3 to 3, but x is going to vary. One of, you know, that I don't know how to explain it exactly, but x varies in the first dimension, whereas y varies in the second dimension. Okay. And then we create fake data here, just that's these 3 lines. And it's just, you know, we could equally have be plotting random data. Let's see what shape. Okay, 240 by 240. Okay, so now let's I want to save this for later, but I don't want to use it right now. Okay, so now the next interesting thing to do is to plot this data. So we'll plot Z. So we create an axis just like we did before for lines and scatter plots, and now we're using this. It's pretty convenient just to use the function subplots, which creates a figure and an axis and a single axis by default. To show the color data here, we just write imshow Z. Now, I guess, yeah, actually, now I'm learning something. By default, so imshow, it's a function that's designed for showing images, but which has a convention for like what, you know, like how you orient the image. But this convention, you know, typically the way that we think about data, this convention is actually reversed compared to our ordinary convention. So if we put this argument origin lower here, let me and maybe it's confusing to see the difference between the two. If you just say imshow Z, it's going to plot the data. Basically, it's going to plot it upside down. So it behooves you to always use, basically, unless you're analyzing images, you're probably always going to use origin lower when you use imshow. But yeah, this is what it does, which I think is pretty interesting. By default, I think it's using, it's making the data look smooth. If you want to see, oh no, that didn't work. Linear. Well, anyways, I'm actually surprised that it looks like that, but
Greg?
Yeah.
Sorry, I could not tell the difference between when you change the origin from the default to lower. Was that something that I missed there?
I'll show it again. So see how the yellow blob is, see how the blue blob is below the yellow blob?
I see it now.
And then in this one, yeah. So this is the, because the data has no meaning, it's hard for me to convince you that it's upside down, but I assure you. Yeah. Actually, one easy thing to do, if you plot Y, oh, it doesn't work. Oh, whoops, okay. If we just plot Y, so this is that coordinate. So Y should vary. So, you know, blue is small values and yellow is large values. So if I don't put origin lower, then the large values. So this is just if you make a plot and you're like, wow, my data is upside down, this is the reason. And all you have to do is put origin lower in there. Okay, now, you know, it uses a default color map when you make this plot, which is called Viridis. That's the name of the color scheme. But sometimes we want to use a different color scheme. So let's show, okay, so to change the color map, we use this keyword argument CMap, and I just wanted to see red, yellow, green, okay. So if we want to change the color map, we use the argument CMap, and we can say for example, red, blue. I actually usually like to use, so red, blue plots. Well, let's go back to the, I think, here it is. That one second away. Oops. Okay, so Viridis, the blues are small and the yellows are large. And so you can see by default in red, blue, the blues are large and the red is small. I typically actually like, if, for example, if you're plotting temperatures, then we usually think of blue as being cold or small temperatures and red as being large or high temperatures. So to do that, the color map red, blue, _R, which means it's reversed compared to the typical red blue, is a nice one. And so that's one that I use. You want to use a red blue color map like this, which the value in the middle is 0, the value that represents 0 is white. And then the negative values are blue and the positive values are red. That's a useful color map to use when your data should be symmetric around 0. If you have data that instead, so that's if you have data that instead that varies, is a sequential data, so it's not symmetric around 0, but it's like all positive or something, then sometimes you prefer to use a color map like Viridis, or there's this other one, red, green, is that right? Yeah. I guess that's, you can read more about, if you Google, you can find a list of all the color maps that are supported, and you can find information online about like which color maps are appropriate for what kinds of data. And so I encourage reading more about that. Okay. Well, I think actually that's probably the most useful thing. Like contour plots are not as useful, so let's see, maybe I'll just let's look at how to. So one thing I'd like to do with this plot actually is rather than plotting the data all smoothed out, I want to plot. Let me try something here, see if it works. Okay, yeah, that's what I wanted. Okay, so I just wanted to illustrate what would happen if you plot it. So here I'm plotting data that it's very coarse. There's only 10 points in both directions, and you can see. Let's do it red, blue. It looks pixelated. You can see each square. So I think this is kind of what's this like how this appearance can be changed by changing this interpolation keyword argument. So let's see if we here. Okay, yeah, right. So by default, I think the interpolation is a nearest. Okay, which actually it just plots. So it plots each pixel as a solid color, and then there's like a sharp line that distinguish that between each pixel. If you want it to look smoother, you can change this interpolation keyword argument from nearest to bilinear. Although I have to say, it doesn't look that great, but that's an option available to you if you would like. Yeah. Okay. Great. I just changed the data to plot random data because actually here. Shit, didn't need to do that. Okay, let's go back to this original example. I'll show you how to change this. So the reason why it's so refined is because it's on a very fine grid. So I can make the grid coarser. We'll make it 10 times coarser by changing that. Yes, perfect. Okay. Okay, so that's a little introduction to heat maps. And I think I should go back to the original. And I think the other, let me figure out how much more time I'm gonna have. Okay. So a heat map, this function imshow, which creates what we call a heat map, is a very simple and fast way to view data. But sometimes you, well, okay, we're gonna go for 10 more minutes. But sometimes it's useful to use, so sometimes you want to, basically you want a smoother plot, because like what I was showing here, let's go back to the course situation. Sometimes it's nice to see have like a very accurate view of your data when it's coarse like this, but other times you might want to have a smoother plot. So one possible smoother plot is created by a contour plot. So this, I just created a contour plot of Z, and the difference now is that those so where it was, let me get rid of this. Okay. So where it was pixelated before, right in here, now you can see it's drawn contours around the data, which sorry, there's a question. Do you think we can carry out satellite drive bathymetry? Definitely. You can definitely do that. That might be illustrated in the next tutorial, which will start pretty soon. Next tutorial is going to go over Car2Py, which is a way of creating maps with Python. So yeah, when you're viewing bathymetry, yeah, I like to use imshow actually for bathymetry, because for stuff like that, you get imshow. I think it gives you a more faithful representation of the data. You see exactly what the points are. But in any case, contour is sometimes useful. And there's two types of contour plots. One is a line. Yes. So yeah, bathymetry hopefully will be coming up next. There's two types of contour plots. One is a line plot where the contours are drawn and the lines are colored according to the magnitude of the function being plotted. And then there's also a filled contour plot, which uses the syntax contour F. I usually prefer filled contour plots to ordinary contour plots, because I think it creates images that are easier to interpret. One reason why that may not be the case is if you're plotting like a lot of pieces of data on top of each other, then sometimes you do want to use these just line contour plots. The other advantage of a line contour plot is that it's easier if you're going to add labels to each contour, like it's done in this example. Then it's a little bit easier to see the labels. So this example goes over adding the levels. So let's put that in. Okay. So one of the tricky things about contour plots is that oftentimes, well, actually, sorry, the power of contour plots, I guess, is that you can choose where to draw the contour lines. So for example, this code uses a range of values from -2 to 2 with 0.25 spacing. So this creates quite a few contours. And I'll just show you what happens when if we decrease the spacing from 0.25 to 0.5, then it's going to create fewer contours, right? So let's just go back to 0.25, you see? And is there a question? I think there might be a question. Oh, maybe not. Yeah, so then if I change it to 1, then it's probably even more. Hi, Kebwe. Okay, the next instructor is here. I was basically done just showing, I was just getting into heat maps and contour plots. And we sort of made it to the end. I think there's a few more things to show, but In my opinion, we did the most important part of heat maps and contour plots. So there was a question, when I showed this plot, can we use this kind of function to plot bathymetry derived from a satellite? So I told them that doing that kind of thing might be covered in the next tutorial on Cartopy. Okay, so are there any final questions for me before we go on to the Cartopy tutorial? Okay. And yeah, as we said before, we're gonna upload the recordings of the lectures after they're done. So I think we should stop recording and then start a new recording.
Yeah.
Yeah. Okay, great. So I'll stop now.